If you still think Databricks is just a glorified data lakehouse company, you are missing the biggest architectural pivot in enterprise tech today. Databricks is positioning itself to be the foundational runtime engine for autonomous AI agents. They are betting their entire $134 billion valuation on a simple truth. The shift from humans querying databases to autonomous agents reasoning over data requires a complete overhaul of database storage, security governance, and semantic context. You cannot just slap a large language model API onto a legacy database and call it a day. You need what we call the 3 pillars of agentic infrastructure. First, a database designed for agents to read and write instantly without corrupting production systems. Second, a security and governance plane that controls not just who can read a table, but what an autonomous agent is allowed to do when it starts calling APIs and executing code. And third, flawless semantic context, so agents do not hallucinate your revenue metrics and make disastrous business decisions. Today, we are going deep into Databricks' $7 billion war chest and their aggressive roadmap for 2026. We will break down the financial milestones funding this pivot, dissect the tech behind their brand new stateless database architecture called Lakebase, and explore their autonomous data coworker called Genie One. We will also look at their next generation hardware partnership with NVIDIA, their deep integration with OpenAI's GPT 5.5, and how their acquisition of Panther is designed to destroy legacy security, information, and event management systems by unleashing swarms of security agents. This is the blueprint for the agentic era. Let's get into it. Financial milestones. In February 2026, Databricks announced they have crossed a staggering $5.4 billion revenue run rate, representing over 65% year-over-year growth. Their net retention rate sits above 140%, meaning existing customers are aggressively expanding. Over 800 customers spend more than $1 million annually, and more than 70 have crossed the $10 million threshold. Their AI product suite alone has surged past a $1.4 billion revenue run rate. This hypergrowth is why the world's most sophisticated financial institutions are throwing cash at them. Databricks secured over $7 billion in new capital, including a $5 billion equity financing round at a $134 billion valuation, backed by JP Morgan Chase through their strategic investment group, alongside Microsoft, Goldman Sachs, Morgan Stanley, and the Qatar Investment Authority. This capital is explicitly earmarked to scale 2 key technologies, Lakebase and Genie. This is not a victory lap, it is a declaration of war on legacy database and business intelligence vendors. Portfolio Pillar 1, the database runtime, Lakebase and LTAP. Every database running today, whether it is Postgres, MySQL, or Oracle, is a monolith. They rely on 2 things sitting on a single machine's local disk: the write-ahead log, which makes writes fast and safe, and the data files, which make reads fast. This design causes catastrophic data loss risk when nodes fail, expensive read replicas to scale, costly standby clones for high availability, and performance drag when analytical queries hit transactional systems. This is blowing up this paradigm with Lakebase. Lakebase takes Postgres and makes the compute layer entirely stateless by externalizing the write-ahead log and data files into 2 independent cloud services: Safekeeper, a distributed durable log service, and Page Server, a scalable storage compute service for page reads. Because the Postgres compute engine no longer manages local storage, it becomes stateless. You can scale reads elastically without copying the database, get high availability without idle standby clones, and branch a multi-terabyte database instantly for sandboxed development or testing, with zero impact on production. Brushing Databricks is also pioneering a new category: lakehouse transactional analytical processing, or LTAP. For years, the industry chased hybrid transactional analytical processing, or HTAP, which tries to run both transactions and analytics in a single engine. In practice, heavy analytical queries contend with critical transactions, slowing everything down. LTAP solves this by unifying at the storage layer instead. Operational data is written once in open columnar formats. Both your Postgres transactional engine and your Lakehouse analytical engines read from this single shared storage layer. There is no complex change data capture or CDC pipeline, no second copy of data, and zero slowdown to your transactional workload. For an autonomous agent that needs to analyze historical trends and immediately execute a transaction, Lakebase and LTAP are the only way to operate at the speed of AI. Pillar 2. Governance, security, and compliance. If you are still thinking about governance in terms of role-based access control, you are living in the past. In the Agentic era, hundreds of thousands of autonomous agents are querying, reasoning, and executing actions in real time. They are calling large language models, invoking tools, and connecting to external APIs. Databricks is overhauling Unity Catalog, turning it from a static system of record into an active, runtime decision maker for AI. The crown jewel is the Unity AI Gateway, a centralized governance layer sitting between your models, agents, and tools. You can register and govern Databricks-hosted models, external APIs, and Model Context Protocol, or MCP, services alongside your structured data. If an agent needs to connect to Google Drive, Slack, or Jira, those connections are governed by the same access controls and auditing pipelines you use for your databases. Contextual service policies evaluate actions dynamically, allowing, denying, or requiring human approval for specific agent actions in real time, like preventing an agent from writing code to a production folder or exposing personally identifiable information. The gateway also acts as a financial firewall, with budget caps across all model providers. If an agent enters a runaway token loop, the gateway kills the request instantly. Databricks is also introducing attribute-based access control, or ABAC. Instead of managing static groups, you write policies using identity attributes synced from Okta or Entra ID, alongside context attributes. You can allow a human employee to view sensitive financial data, but block an autonomous agent from accessing that same data when it queries on behalf of an external application. On the semantic side, Unity Catalog Semantics provides a shared, governed source of truth. Glossary offers an authoritative taxonomy of business terms, with Genie code drafting pages and flagging drifted definitions. Domains group data and AI assets into logical, business-aligned categories, so you can restrict an agent's scope. Metrics let you define critical KPIs like churn, revenue, or active users, once as governed, reusable objects, with materialization pre-computing results for instant queries. And cross-cloud and cross-region addressability via a 4-level namespace means every asset gets a unique global address. You can run workloads on AWS, Azure, or GCP, and Unity Catalog enforces the same policies, maintains a single audit trail, and tracks column-level lineage across your entire estate. For identity management, Databricks introduced Automatic Identity Management, or AIM, generally available for Microsoft Entra ID on AWS and GCP, with AIM for Okta in public preview. No more skim synchronization scripts. The moment a user or service principal is added to Okta or Entra ID, Databricks automatically provisions them with correct permissions. For external access, context-based ingress or CBI lets you write zero trust access policies to securely expose a Genie dashboard or AI gateway endpoint to external users while keeping your broader workspace locked down. Inbound Private Link now supports account-level resources like Genie, keeping data isolated from the public internet. And the Private Network Gateway, in private preview on Azure, provides a single secure bridge between Databricks serverless and your private network. On compliance, Databricks is systematically removing roadblocks. They achieved high-trust certification across all 3 major clouds, ISMAP certification in Japan, and are rolling out support for Saudi Arabia's National Cybersecurity Authority frameworks on GCP. On AWS GovCloud, they added support for Databricks apps, model serving, and Genie. FedRAMP High support is coming to Azure Commercial, and then there is the acquisition of Panther, a leading AI Security Operations Center platform. Legacy Security Information and Event Management, or SIEM, systems rely on manual data ingestion, handwritten detection rules, and human analysts triaging alerts. Databricks is combining their security lakehouse, Lakewatch, with Panther's platform. Panther brings over 100 pre-built integrations, detection as code in standard Python, and agentic SOC workflows. When an anomaly is detected, an autonomous security agent spins up, triages the alert, queries Lakebase for historical context, maps the blast radius, and proposes remediation or executes automated containment through Unity AI Gateway tool calls. With Panther, Databricks is making security, data, and AI the same problem. Pillar 3. Semantic context and the agent platform. If you have ever deployed a standard large language model inside an enterprise, you know the dirty secret. They fail at answering real business questions. Not because the models are dumb, but because your business context is a fragmented mess, scattered across SQL queries, dashboards, Slack threads, and outdated wikis. When an agent cannot find ground truth, it hallucinates or enters an expensive loop of iterative probing. Databricks tackles this with Genie Ontology, Genie One, and Genie Agents. Genie Ontology is a living context graph that crawls your entire data estate, extracting knowledge, mapping metric definitions, and charting relationships between data assets. To determine what is actually true, Databricks developed a PageRank-style algorithm for enterprise data, evaluating where a definition came from, who wrote it, how often employees rely on it, and how fresh the data is. On a real-world enterprise data analysis benchmark, Genie achieved an 84.5% first-attempt accuracy rate, compared to 52.4% for the strongest general-purpose coding agent and 25% for the weakest, while running twice as fast. Forbidden Genie One is the coworker interface, embedded natively into Slack and Microsoft Teams. You mention Genie in a channel, and it can pull data from your lakehouse, cross-reference it with your calendar, write a daily executive brief, or update a business review document with live metrics. Genie Agents takes this further, turning curated chat boundaries into fully autonomous domain-specific agents that you spin up with a natural language prompt. They can reason over unstructured data like PDFs alongside structured SQL tables, execute multi-step workflows through model context protocol connections, schedule tasks, generate documents, and write back to your systems of record, all governed by Unity Catalog. To build and scale these agents, Databricks launched Agentbricks, already powering over 100,000 agents, processing more than 1 quadrillion tokens per year for enterprises like AstraZeneca, 7-Eleven, and Block. Agentbricks solves 3 problems: choice, context, and control. Choice means matching the right model to the right task. Agentbricks integrates all frontier models, including OpenAI, Anthropic, Gemini, Qwen, and Kimi, with a partnership with SpaceX bringing Grok models natively into the ecosystem. Databricks also trained a custom data agent using reinforcement learning on their own AI runtime, matching the performance of Claude Opus and Sonnet on data tasks at a fraction of the cost. Orchestration supports LangGraph, Crew AI, or Claude Code, with horizontal autoscaling inside Databricks apps, or management via Omnigent, their open-source meta-harness. Context means giving agents the right data. Model Context Protocol support extends to Unity Catalog, letting agents securely query Jira, Slack, and GitHub. The Document Intelligence Suite, now generally available, offers native SQL functions like AI part document and AI edit for parsing complex PDFs and images. A managed agent memory service, powered by Lakebase, lets agents persist session history and share memory with other agents. And when an agent needs to execute code, Databricks spins up a sandbox, a secure, isolated virtual machine with downscoped Unity Catalog access. Priced Mayor means governing these highly privileged actors. Every agent trace, memory execution, and reasoning step is written directly back to your lakehouse. You can query those traces to debug behavior, optimize token spend, and monitor performance. Integrating with LakeWatch triggers automatic alerts for personally identifiable information violations or suspicious access. You can even write contextual policies directly in SQL, stating that if an agent accesses a table containing customer personally identifiable information, it may email a summary internally, but is blocked from publishing that data externally. On the frontier, a deep partnership with OpenAI to bring GPT 5.5 and Codex directly into the ecosystem. GPT 5.5 is built for agentic work, complex document reasoning, and long-horizon coding. On Databricks Office QA Pro benchmark, built from 89,000 pages of dense US Treasury bulletins, GPT 5.5 set a state-of-the-art score of 64.66% on raw document reasoning, a 13% leap over GPT 5.4. In the full autonomous agent workflow, where the model must find documents, parse data, and compute answers on its own, GPT 5.5 scored 52.63%, compared to GPT 5.4's 36.10%, a 46% reduction in errors. NVIDIA partnership. The rise of autonomous agents breaks the traditional division of labor where graphics processing units handle model training and inference, while central processing units handle everything else. When an agent executes a task, it calls a large language model on a GPU, but then parses the response, spins up tools, runs SQL queries, writes Python code in a sandbox, and decides the next step, all on traditional CPUs. Legacy CPUs are choking on this workload. Databricks and NVIDIA are introducing support for the NVIDIA Vera CPU, a next-generation ARM-compatible processor designed for agentic workloads, reinforcement learning, and CPU-based data analytics. The Vera CPU delivers up to 3 times faster SQL queries and an 80% boost in agentic performance. This enables an end-to-end accelerated stack. Models run on NVIDIA Hopper and upcoming Rubin GPUs for inference, while the agent harness and tool calls run on Vera CPUs. Databricks is also bringing the NVIDIA Agent Toolkit directly into Databricks apps, letting you host NVIDIA's open-source development platform with guardrails, retrieval augmented generation, and multi-step reasoning, fully governed by Unity Catalog. And by integrating Genie code with deep NVIDIA hardware expertise, developers can debug GPU workloads conversationally, with Genie code natively understanding CUDA, cuDNN, NCCL, and NVIDIA profiling tools, baked into Databricks notebooks, MLflow, and model serving. The new category, enterprise spend on business intelligence software, reached nearly $35 billion in 2025 and is on track to double to over $72 billion by 2034. But traditional business intelligence only improves the inputs to executive decision-making. A dashboard is a passive mirror reflecting a problem. Once an executive spots an issue, the decision-making process devolves into the same manual, fragmented workflow used for 30 years. Meetings, debates, PowerPoint decks, emails, spreadsheets, and project trackers. Is introducing decision execution platforms, or DEPs, to run the executive decision-making process end-to-end. A DEP breaks the decision loop into 4 stages. Signal, real-time detection of changes against critical KPIs. Decision, autonomous agents generate concrete recommended actions with viable alternatives and predicted impacts. Execution, with one click, the system pushes the chosen action directly into your systems of record, whether that is SAP, Salesforce, or supply chain software. Outcome, the platform automatically tracks results, measuring predicted impact against actual realized impact. Every signal, decision, and outcome is written to a centralized decision log inside your data plane, becoming a training dataset that improves future recommendations. In an early deployment for a Fortune 100 retailer, a DEP is targeting a fulfillment cap valued at over $100 million a year. Databricks announced open sharing at the June 2026 Data and AI Summit. Hosted by the Linux Foundation, open sharing is the evolution of Delta sharing, the most widely adopted open protocol for secure, zero-copy data sharing, used by Stripe, SAP, and Atlassian. Open sharing extends this philosophy to the entire AI stack, providing the world's first open, vendor-neutral protocol for securely sharing agent skills, AI models, and unstructured data. It adds native support for Apache Iceberg APIs, so providers can publish once and reach every client, neutralizing format lock-in. And through integrations with MinIO, Cumulo, and Everpure, with NetApp, Dell, and Pure Storage coming soon, open sharing allows cloud-native AI models and agents to connect directly to on-premises assets with zero-copy access. As CTO Matej Zaharia put it, the agentic era deserves an open foundation. When you step back and look at the scale of what Databricks is assembling, the picture is clear. This is a coordinated convergence of data, storage, security, governance, and compute power, all designed for one purpose: to own the runtime of the agentic era. Lakebase gives autonomous agents a stateless, real-time database. Unity Catalog and the Panther acquisition establish a secure control plane that governs and defends agents at machine speed. The NVIDIA Vera CPU ensures the physical hardware is optimized for this new dual-loop compute reality. Genie One and Agentic provide the semantic context and developer platform. And decision execution platforms move us from passive dashboards to active execution. By donating open sharing to the Linux Foundation, Databricks is betting $134 billion that in the agentic era, openness wins. The companies that win will not just be the ones with the smartest models. They will be the ones with the most robust, secure, and context-rich data foundations. That is all for this episode. If you want to dive deeper into the technical specifications of Lakebase, the benchmark data for Genie One, or the architecture behind the Panther acquisition, check out the links in our show notes. Thanks for listening, and we will see you next time.